This is going to be a very important trig review, and thank God this paper should at least be readable. So, trig, the sine, cosine, tangent all come from angle measures. So, sine is opposite of a hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite of adjacent, it's also sine of a cosine. Cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. You got to memorize these values. The sine of 30 is 1/2. Sine of 45 is rad 2 over 2. Sine of 60 is rad 3 over 2. Cosine of 30 is rad 3 over 2. Cosine of 45 is rad 2 over 2. And cosine of 60 is 1/2. The tangent of 30 is rad 3 over 3. Tangent of 45 is 1. And the tangent of 60 is rad 3. The cosecant, secant, and cotangent, we're not going to go right now because all we have to do is flip these. I do want to note, though, that the cosecant of 60 and the secant of 30 are 2 rad 3 over 3. That you might want to memorize because if you don't memorize it, you're going to have to do rationalization, and it's like the most annoying. I'm not going to go through all the other ones because they're pretty basic and straightforward and we don't have time for them, but I did want to point out those two because it's such a weird number. You can do things like adding trig values together, having to express them in just sine and cosine. We do use squares. Square just means that like for example, tan squared of 60, you take the tan of 60, which is rad 3, and then you just square rad 3 and get 3. You can have, sometimes when you simplify, you do get like sine squared or cosine squared or things like that. And then, yes, this is just a lot of calculator stuff where you plug in sine, cosine, tangent, put your angle in. You might need to multiply by the side, but, you know, this is sine -1, so you need to go to second sine, second cosine, second tangent if you're given the sides, and you need to find the angle. That's what we call inverse trigonometry. This is how you have to measure the angles, again, inverse trigonometry. You also might need to find the values of all 6 sides, so just remember sine, cosine, tangent, how you find them. As a matter of fact, you really only need to know sine and cosine. I would just say no tangent as well, because it's going to be a lot harder to do sine over cosine. Just know that, and the reciprocal, it's not even on a calculator. You just do 1 over, though. 1 over, take the reciprocal of it. It's pretty easy. Like, if the sine of theta is 3/5, the cosecant is going to be 5/3. Secant 5/4, the cosine 4/5. You just got to know, though, that that secant goes with cosine and cosecant goes with sine. It's not sine secant and cosecant cosine. That's not how it works. Then you have standard position. This is how a counterclockwise goes, positive, and this is clockwise, so again, negative. You need to know which quadrant they fall in, and again, drawing a picture, very important way. We do use swirlies here. When an angle is over 360 degrees, we do use swirlies. Find the smallest positive angle coterminal. Yes, that means that if you have an angle like 225, you do still add 360 to get 585. A coterminal angle is an angle you add 360 to it. That's just how coterminal angles work. And finally, the last thing you need to know is radians. So this is, again, your trig stuff. And again, if they give you a point, you need to find, you're going to be given the 2 legs, and you need to find a hypotenuse. They can get really ugly with all the rationalization that you have to do. So a radian. So you have 2 pi radians in a circle for 360 degrees. Pi is 180 degrees. Theta equals S over R, and this is used for intercepting arc length. So remember, 1 radian is 180 over pi degrees, so about 57.3. It's what happens if, if this was equal to the length of the radius, and then that's how many degrees it is. That's how we convert. You do use a little bit of dimensional analysis in some of the conversions. I think that, I don't know what the dimensional analysis actually really is. Oh, yeah, here. Like when you do all that to get them on the same side. And then again, that's how you get your angles. It can be a little bit tricky. Like when you have 4 radians or 2.5 radians, that you need to use a calculator for, but everything else you can probably do in your head, and you will need to for pre-calc. Again, and then this is like the angle positions. You need to know, like for example, how to convert them, but soon it's going to come naturally because most of trig will be with this. And there's going to be a lot of arc length stuff involved as well. So, like, for example, in this problem, if you have a 20-foot leash and the leash makes a 55.8-foot thing, you have theta equals 55.8 over 20, and you get 2.79 radians. That's how it works. So, getting theta usually isn't that bad. All right, so that's just your introduction to trigonometry. I hope that you enjoyed this video. It's nice to not have a blowy screen for once. And this is just a bit of a nice video. We have a quiz tomorrow, and I know that the quiz is going to be, for people in my class, it's going to be in like 10.5 hours from the recording of this video. But I still hope that you enjoyed it anyway. And if you ever need this video in the future, you know where to watch it, and you know when your quiz times are. Oh, by the way, for a lot of the other classes, they're intermittently throughout the day, but, like, nothing more than, like, 15.5 hours after the recording of this video. And that's just a recording. Who knows when it's going to actually be uploaded to YouTube.